Okay, so now see here. So this is going to be from this final circuit only. I'm going to measure all the parameters like input impedance, output impedance, voltage gain, and current gain. I'm going to measure. Okay, so we are going to measure all the 4 parameters for all the different types of common emitter amplifier with different types of biasing. First one, input impedance. See the input side. What all resistance you have at the input side. What all resistance you have at the input side? What all resistance you have at the input side? Shakti Prasad,
RB and I
RB and IE.
that
RB and
HI
how are they connected? Are they in series or parallel?
parallel.
How do you say it is parallel? It is correct parallel, but how do you say it is parallel?
Current is dividing, sir.
Very good. So what is the formula for parallel combination? R1 parallel to R2 is what?
Uh, 1 by RP is equal to R 1 by R1 plus 1 by R2.
Okay, same thing for the here you are having RB and HIE are parallel, so I can write ZI is equal to, see here, RB parallel to HIE. Is it clear? You have to look at the input side. You have to look at the input side and see how the resistance are connected. If you are still not clear how to find whether it is series or parallel, you inject a current here. This current will split into two. The current is splitting, the resistance are in parallel. So two resistance I have RB and HIE. So RB parallel to HIE is going to be the input resistance. If RB is very, very large, then input impedance is approximately equal to HIE. Assume RB is large, assume RB is infinity. Anything parallel to infinity is that resistance. Okay, so ZI will be approximately equal to HIE. Any doubt in input impedance computation? See, there is no mathematical steps for finding. You have to look at the input side and see what all resistance are there first. You have to identify the resistance. Here I have two resistance, RB and HIE. Second step, you have to see how they are connected, whether they are in series, whether they are in parallel, whether sometimes you have combination of both series and parallel. That time you have to apply the resistance simplification formulas. Okay, so here it is very practical and simple to locate RB and HIE are in parallel. So RB parallel to HIE. And when you do parallel combination of resistance, what is the result? When you do parallel combination of resistance, what is the result? What can you say about the effective resistance? Will it increase or decrease? When you do parallel combination of two resistances, it will increase or decrease.
Decrease.
What
Decrease.
what is the parallel combination of 4 ohms and 4 ohms? Two 4 ohms are connected in parallel. What is the effective resistance?
2 ohms.
2 ohms. It is decreasing, right? So here the input impedance is decreasing. Ideally, input impedance should be high or low as per our requirement. The input impedance should always be very high, right? I told you the reason. But here it is very, very less because you have a parallel combination of the resistance at the input side. Is the input impedance computation clear to everybody? See, it will not be same for circuit to circuit. The input impedance computation will be slightly